Okay, so this again is just a review of what you were supposed to finish over the summer. All right, so it shouldn't be anything new. You should be pretty good at it. Now on the first page, I'm trying to see like number 6. Here's what I want to talk to you about, number 6. All right, I want to say this one more time because this is one of the most missed questions on all standardized tests. All right, it deals with more than or less than. It deals with more than or less than. All right, if it's 91 more than the square of n, are you adding 91 or is it 91 plus? You're adding 91. Now, that's not something I can explain to you easily. You just have to look at it and kind of say 91 more than. It's either plus 91 or 91 plus. Where are you starting? You're not starting at 91. You're starting at the square of a number. So that would be n squared plus 91. Thank you. Yes, we're getting there. All right, we're getting there. All right. Now, number 8. 2/5 the cube of a number. All right, you're multiplying 2/5 times the cube of a number. So that's just 2/5 x cubed. That's what that is. All right. Now, did anybody read any of those and go, man, I'm just not really sure? All right. Well, let's just do this real quick because I think we can. The difference of 10 and u. 10 minus u. The sum means to do what? Add. So it's 18 plus x. Does the variable matter? Does the letter? No. All right. The product of 33 and j. 33j. 74. Now, in this case, 74 is being increased, so that's where you're starting. So it's just 74 plus 3y. 15, are we starting at 15 or are we subtracting 15? We're starting at 15. 15 is where you start. So 15 minus twice a number. And 3/4 the square of b, 3/4 b squared. So everybody agree that's pretty easy, right? All right, exponents and order of operations. Again, there's a couple good ones here, especially the fraction problems I want to take a quick look at. All right, I definitely want to review that. And listen, if you're a little, if you, forgot some of the rules, please pay attention carefully. I'd like for you to leave St. John's being a master of fractions. That's why I put those on there. All right, you have to know how to do fractions without calculator. We don't really need a calculator right now. All right, I don't want you using a calculator. It's all about mental math. All right, so let's do this. Obviously, 8 squared is what? 64. 11 cubed is obviously. Now, does anybody remember the rules for multiplying by 11? Why did I know that? All right, let me explain to you. Do you remember?
Don't you just put the 3 times 11 in the middle of 11?
No, look here from now on. If I said 11 times 11, look, 11 times 11. Anytime you're multiplying by 11, the first number comes down, then you add these two numbers, and then you leave the last number. So it's 121. So if I say 121 times 11, 1 comes down. What's 1 plus 2? 3. 2 plus 1. And then you end at a 1. All right, so if somebody asks you what 1331 times 11 is, it would be what? 1 what? 4. No. 146. 41. Right? Again, that's a nice little thing to know how to multiply by 11. All right? Now, again, the first number goes down, then you add, last number stays. All right, it's very easy. All right, now we're going to do one more time. We're going to multiply 14641 times 11 because there's a problem now with that. All right? So generally we start from the right. Generally we start from the right and go the other direction. The reason why I start on the left, because in my mind I quickly scan and realize that when I add, I don't go above 9. All right, so please look. All right, so when you multiply 14641 times 11, it's 1. And then 4 plus 1 is? 6 plus 4 is? 4 plus 6 is? But why am I putting a 1? Because you carried it. That's all there is to it. All right? And then 4 plus 1 is? But it becomes 6. And then a what? 1. So if somebody has a calculator for me, all right, I want you to type in on your calculator 14641 times 11. Very nice. All right. So those are just little techniques. All right. Those little techniques that kind of help you out if you're taking a standardized test and you're not allowed to use a calculator. A lot of times they incorporate those into the questions. All right. So now back on track. All right. I don't really think anybody should have trouble with 11. Kind of simultaneously tell me what the answer is. 30, right? All right. We're going with mental math here. We're going with mental math. Anybody have any questions? All right. You should know order of operation. All right. Now, here's one where some people might have a problem. What do we do first here? Exponent. Okay, so that's no big deal. That's 25. Now what do we do?
6 divided by 4.
Yes, you have to do 36 divided by 4, which is 9 times 3, 27 minus 25. That's really kind of what I want. All right, that's really kind of what I want. Now, does everybody understand if you did the 4 times 3 first, you get a wrong answer? All right, you're not doing multiplication first. All right, it's done in order from left to right. It's done in order from left to right. All right, so let's look at 13. All right, so we should be able to do inside here real quick. All right, what is that? How did you get that? Is? There you go. And now how many times does 54 go into 162? 3 times. All right, I'm pretty happy with that. I really would like for you to be that good at the mental math. All right, I don't want you using a calculator. I don't want you writing it all out. All right, I want you knowing the order of operation. All right, so let's talk about the numerator. The numerator here is what? I think it's what? 70. All right, 70. And the denominator is what? -7. Now, again, listen, here's where I'm trying to tell you. You're doing the work, and if you disagree, you raise your hand. That's what you do. You're trying to figure out if you understand order of operation. If you can see 70, move on. If you know the answer is -7, let's move on. If you don't know that, you raise your hand and say, just give me a little bit of help. I forgot a rule. That's all I'm asking for. What? Come on, Connor.
8 to the second power is...
All right. Now, final answer here then is -10. All right. Now, I want to review with you this real quick. All right. If I said -2 squared, what's that answer? Now, this is where people are making mistakes. So I want to teach you a bunch right now. Listen to me carefully. I'm going to highlight this right here. That doesn't mean -2. I want you to think of that as meaning the opposite. All right? That means the opposite of 2 squared. What's the opposite of 2 squared? So the opposite, what's 2 squared? 4. So what's the opposite of 4? That's why that is written as -4. All right. Now, if I said this, what's that answer? That's 4. Because this time that means -2 times -2. All right. So this is the problem that everybody misses on the first quiz. When I do negatives. All right? If it's in parentheses, the negative is incorporated into the problem. If it's not in parentheses, that means the opposite of whatever your answer is. All right? So again, if I just make up a number and I say, for example, negative 3 to the 4th power, you should be able to quickly tell me that's what?
That negative 27. Wait, to the 4th power.
What is it? All right, this is embarrassing.
9.
Look here, right, guys? That's 3 to the 4th. This is how you should be doing the powers of 4, right? No, listen. Okay, Connor, listen. I'm trying to show you something now. All right? So right here, when you're doing something to the 4th power, you're grouping them. It's much easier to do it that way. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. It's much easier to do 9 times 9 than it is to do 27 times 3, even though they're exactly the same. All right? So now my answer is negative 81. All right? My answer is negative 81. All right? Now, again, those are good reviews of what the negative is in front of the number. Again, if I said this, though, if I said negative 3 to the 4th power, of course, that would now be what? Positive 81, because it would be negative times a negative times a negative times a negative. All right, as long as you have an even number of negatives, positive, odd number of negatives, it's negative. All right, so that would be 81. All right, so again, that's a really good review of the parentheses and the negative sign in front of a power. All right. Now, I really want to talk to you about question 15. All right, I really want to talk to you about question 15. All right, when I'm looking at this first, I try to find the easiest way to approach. So in this case, I'm just going to come over here and say, well, that's just 1 minus 2, which is negative 1 to the 4th power is what? We just talked about it. So I can put a plus 1 down. All right, now I'm looking at this, negative 2 cubed, and negative 2 cubed is what? Negative 8, right? However, you see an extra negative out in front, right? So that would be a positive 8. That would be a positive 8. All right? Now, we have a little bit of issue here. All right? Now, to me, we're going to review now quickly adding and subtracting fractions. So I have to get a common denominator, correct? So the common denominator is what? All right, so now here's how I want you to show, or here's how I'm trying to show you how to use it, all right, the most efficient way. So you put a 12. Now, why did I make the line so big there? Right, I made the line so big because both denominators are going to be 12. So instead of writing 2 different 12s, I'm just going to write 1 12. All right, so I'm going to multiply this fraction here by what?
3.
So that becomes 9 12ths. Now I put minus what? 10 12ths. Is everybody happy with that so far? And 9 minus 10 is? So now I have negative 1 12th, and now I have to multiply that by what? 8. All right? And remember, 8 is the same as 8 over what? 8 over 1. And now I can reduce by a factor of what? 4. So this becomes a 2, and this becomes a what? 3, which makes that answer what? Negative 2/3. All right, negative 2/3. All right. Now, 8 plus 1. How many thirds are in 9? Nope, don't. How many thirds are in 9? Think of it as like this. Think of it as you have 9 pizzas, and you have cut the pizzas into thirds. There would be how many? There would be 27. 9 is equivalent to 27 thirds. So the question really is 27 thirds minus 2 thirds. 25. And that would be 25 thirds. All right? As we become advanced in math, we don't use mixed fractions. We always use improper. Quickly. Okay, visualize it like this, like I said. I know it sounds kind of silly, but all fractions to me were pizzas. All right? So you have 9 pizzas. If you cut them into thirds, every pizza is cut into thirds. How many pieces would you have? That's one. I didn't. 9 is the same as 27 over 3. All right? 9 is the same as 27 over 3. All right? Next, all right, let's take a look at number 16. A lot going on here. A lot going on here. And obviously, as we're doing is we are working with addition, subtraction, multiplication, and division. So this is a review of everything. All right? Now, we got to work inside the parentheses first. So how do I handle division? You multiply by the reciprocal. So this is 4/5 times 25/12. All right? And then you're just reducing. All right? So when you're reducing, let's take a look at that. That becomes a 1. That's a 5, 1, and 3. All right? So now I have 5/3 times 6. Is everybody okay with that? And what's 5/3 times 6? 10. Beautiful. That's exactly right. 10. All right? That's 10. All right? Now I have a plus here. All right? Now, I'm just going to bring these down just so you can see, and this is how I would kind of want you to do your fractions. All right? So I would now group what? 10 with 2 3/4. 5 times 6 divided by 3. Shh, no one needs help. Right? Or you could do 6 divided by 3 and multiply it by 5. All right? Now, we have 10 plus 2 3/4, which is 12 3/4. So I have 12 3/4 minus 7 1/2. Connor, listen, I'm not going to have to worry about you. I don't assign seats for a reason. I don't want to assign you a seat. I'm totally distracted by you. Connor, I'm not sure that's a good decision for you. If you want trouble, then you got to make where you sit. Your objective is to avoid trouble. I'm not playing around, Connor. I mean it. Wipe the grin off your face, or we're going to have a parent conference today. No, there's no excuses. You're 8th grade. You have self-control. I mean it. Your parents are going to come in today. Now, I'm at 12 3/4 minus 7 1/2. All right? So in this case right here, all right, we're just getting common denominators again. This should be simple, basic math for you at this stage. 1/2 is the same as what? 2/4. So now 12 minus 7. 5 1/4. That's correct. 5 1/4. All right? Now, I honestly prefer that you leave it as 21/4. All right? We don't write as mixed fractions. All right? Although, listen, if you left it as 5 1/4, it would not be counted wrong. All right? If you have the right answer, I never mark it wrong. I'm just telling you, as you progress, we just don't write as mixed fractions. Everything's improper. All right? Now, we should be able to fly through the properties here. All right? It's honestly a 3rd year now. 6th graders did the same property worksheet yesterday. All right? 7th graders, same thing. All right? For some reason, properties is a big deal on standardized tests. All right? You should be able to just zip through these real quick. Now again, I'm not saying you didn't forget them, but let's just go through real quickly. All right, 3 plus 5 is the same as 5 plus 3. That's called the what? That's right, commutative property of addition. All right, now we have the grouping symbols. That's the sign for associative. So it's the associative property of multiplication. Whenever you multiply by 1, it's the identity, right? Now we say it's the multiplicative identity. All right? Now, for number 20, things are canceling out. All right? So you would say this is the multiplicative what? Inverse. Good, just what I thought. All right? Number 21 is the disguised what? Property. Yes. 21 and 22. Yes, they're the distributive property. 21 and 22 are both the distributive property. All right? 23, when you add 0, you stay the same. That's a what? That is the additive identity. That is correct. Grouping symbols, correct? Order stays the same, so I know it's the associative property of addition. Now I'm trying to trick you on 25. What is that? Definitely not associative. What? Is the order the same? I don't think the order is the same.
Yeah, because
I'm asking you, is the order the same? It's a yes or no. No. All right, whenever the order is changed, it's always the commutative property. All right, commutative property of addition. All right, 26, we're canceling things out. When you cancel things out, it's called a what? Nope. It's the inverse, but we say it's the additive. The additive inverse. What? Well, 0 property is when you multiply by 0. All right? These things are canceling out. These things are canceling out. The 0 property is what? 29. All right? 29 is the 0 property. 30 is the what?
oh no,
Additive inverse. All right? 28 is what? Look at the order. That's how easy. Look at the order. Commutative property. What about 27? I'm on 27. Commutative property. True. 31. Yep. Commutative property of multiplication. 32. Distributive. 33. Wow, distributive. 34. Commutative. No, it's a multiplication commutative, right? And then 35. That's definitely the 0 property. And then, yes, multiplicative identity. Okay. All right. Now again, I don't think I want to waste time using the distributive property. You guys can knock that out easily. The only one I would caution you against is maybe 43. Let's look at 43. All right, someone tell me the answer to 43. Maggie, go.
Okay.
Just read it.
Okay, negative 18f plus 27
Beautiful. And Maxine, 45.
negative a minus b plus c minus.
That's how simple. All right, everybody knows the distributive property. All right, so knock those out on your own. All right. Now I want to talk about these definitions here. All right. So in order for us to have conversations about math, you have to be willing, or you have to know what that means. All right. Yes, sir. Okay. What's a natural number? Very good.
Isn't it when like it's any number from the number 1?
That's right. So defining a natural number, 1, comma, 2, comma, 3, dot, dot, dot. All right. Kind of write it in set notation sometimes. All right. Defining a whole number. That's right. 0 and up, not a big deal. 0, 1, 2, dot, dot, dot. integers. Remember those?
Oh, it's like the negative 3.
Yes, the negatives in counting, or the negatives in positive counting numbers. There's still no fractions or decimals being introduced. So how do we write the integers? We do ... -2, -1, 0, 1, 2, so everybody sees the pattern. That's the integers. 0 is definitely an integer. All right. Now, rational number is, I want you to remember this. Rational number, the easiest way to remember it is ratio. Right? So rational number is just any number that can be written as a fraction. That's what rational means. Any number that can be written as a fraction. All right? Now, what do you suppose irrational means then? Any number that can't be written as a fraction. All right? Now, let's talk about irrational numbers. An irrational number, again, is pi. That's a good irrational number. We're going to talk about square roots. If I say the square root of 3, on your calculator, if you type in the square root of 3, it will give you like 1.71, and it'll just be a string of numbers. And those numbers never repeat. All right? So an irrational number is a number that doesn't repeat and it doesn't end. All right? Like pi. Pi is a number that goes on and never stops. They've calculated to almost billions of decimal places. All right? So, a rational number. All right, let me give you an example of a rational number. 1.8, we call that a terminating decimal. All right? If the decimal ends, it's rational because we could write that as 18/10. That can be written as a fraction. The other thing is, what if I said something like 0.6 repeating? Anytime there's a repeated pattern, it can be written as a fraction. And in this case, it would just be 6/9. For those, some of you guys remember that little rule. When you have repeated numbers, you can put it over 9. All right? So if it repeats, all right, or it terminates, you can write it as a fraction. All right? Any questions? Rational, any number that can be written as a fraction. Is 0 a rational number? Yes, because you can just make it 0/1. Is 5 rational? Because you can make it 5/1. All right? Moving forward. All right. So, -3. It is definitely an integer. And it's also what? And it's rational. 0 is a what? A whole number. And it's an integer. And it's what? Rational. Okay? 1.6. Rational. 0.17 repeated. Rational. Pi. Irrational. Simple as that. All right, is everybody pretty good with that? All right. What time do we get out of here, guys? What is it? 9:05. All right. So now, what I want to do is, I'm pretty confident about 57, and I'm pretty confident about 58. I'd like to spend some time on the fraction. So let's take a look at 60. We're going to take a look at 60 real quick. All right. So everybody work with me, 60. All right. First thing we're going to do is subtract 3/4. All right. Now I need a common denominator, correct?
Yes.
So 3/4 is the same as
12.
9/12. Come on. Now I would like for you to say 11/12 minus 9/12 is what? 2/12, but reduces to, thank you, 1/6. That's how you should be doing fractions. You shouldn't say 2/12. All right. So now I have 5/6 C equals 1/6. Now again, you're reviewing your fractions right now. Now, to simplify a fraction or to solve an equation with the fraction as the coefficient, we multiply by the what? multiply by the reciprocal, so everybody's going to put for me 6 over 5 times 6 over 5. Right? What happens to the 6's? So C is equal to 1/5. All right? Everybody happy? Right? Okay, let's take a look now at okay, so in this case, since you asked, we're gonna get common denominators. So 3/4 is subtracting 6/8, right? So -1/2 is equal to -1/8. So now I'm going to multiply by -2, multiplying by -2, so n is equal to 1/4. All right, n is equal to 1/4. All right. Moving forward, stop. You're way, I don't know what you're doing. Interrupting. All right. Now, let's do 64. All right, let's do 64. So now I have 6y minus 5 equals -6y minus 3. Anybody have any questions with that? Now, here is where I want you to be at. I don't want you to put a plus 6y like we did last year. And I don't want you to do that anymore. Your mental math has to be this good. So pay attention to what I'm saying. Here's what you should be doing. You should be saying 12y equals 2, y equals 1/6. If you can't do that, you are way behind. And if you don't see that, now you put your hand up and I'll just show you real quick. It's just a matter of fixing how you're thinking about numbers. If you let me fix how you're thinking about numbers, you'll see it's simple. Anybody have any questions? All right, so I think what's fair is for you guys to have all the way up through 66. That's it. That's all I'm asking. All right, is everybody good with that? There's just a couple more equations to solve, a few other things that I left blank. Do the distributive property. You've got 10 minutes. All right, you can get that done. Right? What did you say? Well, that's fantastic. Thank you. So you're done. All right. So now all we have to do is just go through some of the harder problems on Monday. All right, and double check things. All right.